So. Yeah.
So like this year, do you have to do anything like
Projects?
Yeah.
Maybe. I only do the ones that I feel like doing.
No, that's not it.
Maybe. Alright. Yesterday we did exponential equations with the same base. I'm sorry, make this a 2. Yesterday we did exponential equations with the same base. To do this, because all of the bases are the same, we can use the property of product of powers, which says that if you have two bases being multiplied that are the same, you can add their exponents to get to simplify them. Right? We're using that property. So if the bases are the same, we can add their exponents to get this exponent. And we set this up as an equation and we solve. So this becomes x plus 2 plus 12 equals 2. And then we stop. And we solve for x. Okay, and then to check to make sure our answer makes sense, you can plug this into here, and you'll get negative 12 plus 2 is negative 10. So we have 4 to the negative 10th times 4 to the 12th, and that should give us 4 squared. Well, what is 4 to the negative 10th? Plug it in your calculator. What do you get?
9.536.
Okay, so long decimal.
Yes, and then there's
Okay, leave it in your calculator, and now hit times 4 raised to the 12th. Put 4 raised to the 12th in parentheses, or I guess you don't need to. What does it equal? 16, which is the same thing as 4 squared, right? Okay. All right, so today we're going to look at what happens if this is not the same base. And how do we solve it? So the answer is solve an equation, an exponential equation without the same bases. You have to change it. We've got to change one of the bases. Now we're not allowed to just change it to whoever we feel like. I can't just erase this and put a 4. That changes the equation, right? So I have to replace this with something that's equivalent to it. Now I could replace the 4s, but the rule of thumb is you want to replace the base that is the biggest. So if we've got 8s and 16s, you want to replace the 16. If you've got 2s and I don't know, 2s and 10s, you want to replace the 10. So whatever the bigger base is, that's the one you want to replace. Yeah.
Could we make it 4 to the second?
Yeah, that's what we're going to do. So you need to ask yourself, what can I do to 16? What is the power of 16, by the way?
4 to the second?
Now, what is the power of 16?
1.
1. So what can I change 16 to give me a base? So look at the number 16. It's got a lot of different exponents we could change it to. Can we think of some of them? 4 squared. 16 to the first.
2 to the 4th.
2 to the fourth.
8 to the half.
No. Um, 64 to the 1. No, 256 to the 1/2, I think. Is that right? What's 256 to the 1/2? Yeah.
Can exponents be like
16.
Yeah. Yeah. They can be decimals. They have to be. Well, they can be negative too, I guess. All right. Anyway, so there's a lot of different options, but which one do we want? The one with the 4, right? So you've got to ask yourself, well, what can this be? 4 raised to that power. So it ends up being, 16 to the first is the same thing as 4 squared, right? What happened to my first? It's still there. It's power of a power. So you see how I replaced the 16 with 4 squared? And what is 4 squared of first power? Just 4 squared, right? Okay. The rest of the equation stays the same. And we solve from here. In order to solve from here, you've got to multiply these two things here. 2 times 1 is 2. So I'm just going to erase this and put a 2. But know that there was a 1 there. Okay. Now we solve just like we did earlier. I'm not going to solve this again because you've already solved it once. Okay. Same thing. All right. Let's do another one. Okay, so we need to change the bases. All right? We gotta have them be the same. We can't solve this otherwise. So that means I need to change the bigger one first, right? So let's look at 8. We want to change 8 to something else. So what can 8 be? Not 8 cubed, just 8. What is 8? 8 can be what? 8 to the first power, which is obvious, but it's not going to help us, right? What else? 2 to the third. What about 4 squared? No. That doesn't make sense. That's 16, right? Not 8. Alright, that's pretty much it, right? Yeah. Alright. That doesn't help us, does it? We need it to be a 4. Well, we can't get it to be a 4, so what do we have to do? We have to change the 4s. So we need to change these 4s also. Well, let's look at 4. What does 4 give me? 4 to the first, 2 to the second, right? Bingo. Got the same base right there, right? So we're going to replace these 4s and this 8. This 4 becomes 2 squared. This 4 becomes 2 squared. This 8 becomes 2 cubed. Now here's the part that's a little confusing, but it's not too bad. It's still times and equals. What about the original exponents? They're still there. They've got to go here, here, and here. So this is 2x plus 3. This is 6, and this is 3. They still have to stay there, yeah.
So do you have to, since it's in parentheses, you have to multiply, like do that first and then add it on?
No, if I do that first, I'm back where I started at 4, right?
Yeah.
I don't want to be. I want to keep the 2. But what do I want to get rid of? I want to keep the base, but what do I want to get rid of?
Power.
Yeah, I want to get rid of this 2, the little one, right?
Yeah.
So how do I get rid of the power?
Nope.
I gotta do this times this, and then this times this, and then this times this. Power of a power property. If we have a power raised to another power, we can combine those 2 exponents. So this becomes 2 raised to the 2 times 2x plus 3. This becomes 2 raised to the 2 times 6. And this is 2 to the 3 times 3. See what I did? Now what do I have? Same base, which means that I can solve it. So take your exponents, put them in an equation, and solve. So we have 2 raised to the, 2 times 2x plus 3, what? Plus 2 times 6 equals 3 times 3. Okay. Now that we've gotten rid of our bases, now I can start getting rid of these parentheses and solving for x. This is just an equation. You guys can solve this. Let's solve it together. 2 times 6 is 12. 3 times 3 is... Okay, what do I do with this 2? Distribute by multiplying. So 2 times 2x is 4x plus 3 plus 12. Someone better stop me. Yeah. Thank you. Got to distribute it to the 3, and I'm doing this on purpose because my third mod, a lot of people were making this mistake. They were bringing down this 3. Got to distribute 2 times 3 is 6. Okay. Combined like terms, this becomes 18. 4x plus 18 equals 9. Minus 18 on both sides. You get 4x equals negative 9. Divide by 4. And fractions, you're going to end up with a lot of fractions in this section. We're going to get x equals negative 9/4, which we will leave as a fraction because that's a repeating decimal, I think. No, it's a terminating. Goes in twice in 1/4, so what, 2.25? We'll still leave it as a fraction. Okay. Good? You're good. Alright, go to page 219 and do number 3A. Page 219, number 3A.
No, sir.